Hi, my name is Adil and today we are going to talk about Latch. So what is Latch? To understand this, consider a push button which can remain on as long as we press it. To explain it more elaborately, we can say that we have a push button which has a spring inside it. If we press the button, then this switch completes the electric path. When we press the button, then at the same time energy is stored in the spring of the push button because we applied mechanical force to the button. When we release the button, then the stored energy of the spring forces the button to become open, which means electric path is no more completed. So push button will remain on as long as we press it. Latch uses these push button switches to operate the output. Now you would be thinking that why to use such buttons when we can use usual beautiful looking wall switches. The reason is that in industries or other places like these, there are a few buttons on the control panel to operate the complete system. Let's understand it by a daily life example. You remember in our previous video, we discussed a garage gate example. In that example, we have to press the button until the door is fully closed or fully opened. Now we had a problem in that system that we cannot get away until the operation is done. Latch really automates the system because by using Latch, we press the button and can go away because system can operate itself automatically by just a single pulse or signal. Latch is also useful in many other processes such as controlling a pulse. For example, it will be useful when a pulse is required to activate a continuous output. Also, by using the system becomes more safe because it is now become pulse operated. To understand the latch, let's practice some examples. So in our first example, we have two push buttons and one output device. We want to control the output device in such a way that if we press the first push button, then our output device turns on. And in that on state of the device, our first button has no more effect on the output device. Means after turning on the device, if I press the button again, then output still remains on. But when I press the second button, then the output device turns off. And after that, our device can be turned on by the first button. To understand it more effectively, let's create a program for this. So here I have my WPLSoft 2.46. So let's open it. Click open. And now WPLSoft is opening. Now create a new program or new project. I'm gonna set the title to Latch. And I'm gonna select the PLC type to EX2 because mine is EX2. And click OK. Now maximize the ladder diagram mode. And now according to our statement or example, we have two switches. The first switch was X0, which is a normally open switch, and the second switch is X1, which is our normally closed switch, and our output device is denoted by Y0. So first of all, we have to put X0 here, LD X0, and then we have a normally closed switch which is X1, so LDI X1, and now our output device is denoted by Y0, so we have OUT Y0, and in parallel to this we have to place it LD Y0. You will get to know this in a moment. And now we have to place a vertical line which is F9. Now first of all, compile this program and click on simulator
Click on online mode, click yes, and then run the program. Now you can see we have here two switches, which is X0 and X1, and then we have output, which is our Y0. And how this program works is that X0 is a normally open switch. So when we click it or turn it on, our output device Y0 will turn on, and this X1 is normally closed state, so it will not resist to the electric path which will be created by X0. So if we want to cut the electric path, then we have to turn on this X1 to stop the latch. This is how latch works. So first of all, I turn on X0. Now you can see our output device is turned on. Now remember that X0 and X1 were our push buttons as we defined earlier. So if I turn it off, then you can see our output has no effect by the X0. If I turn it back on, this will continue to behave as same as it is before. So if I turn it off, now we want to break the latch. We want to turn off the Y0. So what we do here is that we will turn on X1. So you can see when we turn on the X1, then our Y0 turned off because electric path is now cut. So means the path which was created by the X0 is now cut by the X1. So if I turn it on, you can see output is not turning on because X1 is not allowing the current to flow through it. So if I turn it off and turn it back on, so now I turn it X0 on, you can see Y0 is again turned on. So if I turn it off, the supply which is given to now Y0 is by Y0 itself, which is now acting as a switch instead of output, which means here Y0 is our output, but here Y0 is our switch. So it gives the supply from here, this path, which means from Y0 to X1 and then to Y0, which is output. Now this Y0 is our output, this Y0 is our switch, but this one is our starting switch, which has now no effect on the output, but this one is the cut-off switch. If I turn it off, then Y0 is off. So this was our example. Stop the simulation, turn off the online mode, and turn off the simulator, and now close the project. Click yes. We need to save it. Sample and name it Latch, and hit enter.
In our second example, we are going to design a garage door, not like we discussed in the previous video, but an advanced one. We want to control the door by 3 push buttons attached with the door. The first button is for moving the door upwards. The second button is for stopping the door at a specific position or in case of emergency. The third button is for moving the door in downward direction. In this setup, we have 2 outputs. The output Y0 indicates that garage door is moving up, and Y1 indicates that garage door is moving down. In addition to this setup, we have attached 2 sensors at the top and bottom of the door. Now what our program do is that when we press the up button, the door is starting to move in upward direction and stop going up until the sensor attached on the upper side of the door gets activated. Now if we press the down button, then the door starting to move in downwards direction and stop going down until this sensor attached on the bottom side of the door gets activated. In the state of moving, when I press the stop button, the door stops at the spot. After that, I again press the up or down button to move the door upwards or downwards after stopping the door. Now what this sensor do is that when door is fully opened or closed, they disconnect the signal to motor or shut off the motor to avoid any damage. I have already created a program for this example. So let's have a look on the program itself.
So here I already created the example which is named as garage door. First of all, we open it. Now WPLsoft is opening up. So here you can see that we have two switches, initial switches to operate, which are X0 and X2, which are for moving the door in upwards and downwards respectively. And our X1 and X3 are the sensors, and our Y0 and Y1 are for the indication for moving the door upwards or downwards direction, and X4 is our stop button. Now you can see that our complete program is created with the help of latch, which means we have to just press the button and then release it, and the system can operate itself automatically. So you can see here X0 is our up button, Y0 is door moving up indication, X2 is moving down button, Y1 is door moving down indication, X4 is our stop button, and X1 is our door upper sensor, which is attached on the top of the door, and X3 is our bottom sensor of the door, which is attached at the bottom of the door. So first of all, we're gonna compile it and then turn on the simulator and then get into online mode, click yes, and then run the program, click yes. Now let's say the door is now closed. We want to open the door. So first we have to press the X0 so that door started to moving up or door becoming open. So if I turn the X0 on, then you can see that door is moving up. Now as X0 and X2 are push buttons, which means as long as I press them, they will remain off, and if I release them, they will turn off. So here I pressed the X0, so it is turned on, and now I release the X0 and now it is turned off. So you can see that door is still moving in upward direction. Now let's say door is fully open and the sensor attached on the top of the door is now activated. So the sensor on the top of the door is X1, so it will be activated, and now our door is stopped moving up because door is now fully opened. Now we want to close the door again, which means door should be moving in downward direction. So we have to turn on X0. So X2 is again a push button, so I press it. Now door started to move in downward direction and I release the X2. Now at the same time X1 will be disengaged, which means it will back on its original state because X1 door is no longer in fully open state. So door is starting to move in downward direction, and let's say door is now completely closed. So our X3, which is the sensor attached at the bottom of the door, is now activated. So if it is activated, now you can see door stops moving in downward direction. Now we want to open the door again, so we have to turn on X0 again, and you can see door is starting to moving upward direction, and again the sensor attached on the bottom of the door is now disengaged, so it is turned off. Now let's say the door is now in the middle position, neither in the up or neither in the down. So if I press the stop button, which is X4, and X0 is our push button, it will definitely turn off automatically. So you can see that our door is not longer moving in upward direction, so it is off. Will be in same position until or unless we again press the upwards or downward direction button. So if I release the X4, it will turn into its default condition. So if I again press the X0 button, then door is starting to move in upward direction. Now this is my logic. Everyone's logic could be different. Your logic could be different. So it depends upon you that you can try it. So I turn off the simulator, turn off the online mode, and get out of the simulator.
In our third example, we have a tank which can mix two different liquids with specific quantities. This tank has two inlet pipes at the top for two different liquids to get into tank. This tank has three sensors which determine the levels to the liquids. This tank also has an outlet pipe at the bottom of the tank. So when liquid mixes up, then liquid flow out of the tank. In the given diagram, you can see a tank in the blue color. On the left side of the tank, there are three sensors. On the top right side of the tank, there are two inlet pipes for the liquids. On the bottom right side of the liquid, there is an outlet pipe for the mixed liquid. Also, there is a start and stop button for the whole process. Now what this system do is that when we press the start button, then first liquid enter from its inlet pipe to the tank until it reaches the level of sensor 2. When liquid 1 fills till the level of sensor 2, then liquid 1 stops entering the tank and liquid 2 starts entering in the tank from its inlet pipe till it reaches the level of sensor 1. When the liquid 2 reaches the level of sensor 1, then liquid number 2 stops entering the tank. Then mixed liquid in the tank starts exiting from the outlet pipe of the tank attached at the right bottom side of the tank. The mixed liquid exits until it reaches the level of sensor number 3. When the tank becomes completely empty, then mixed liquid stops exiting from the tank and liquid number 1 starts entering from the inlet pipe to the tank, and this process continues. If we press the stop button during the process, the system stops at the spot. And to again execute the system, we have to start the process all over again. I already created this program, so let's have a look on this. So I already created a program for the example which I just described, which is named as tank here. So first of all, we're gonna open it. And you can see that WPL soft is opening up. And you can see here we have a lot of sensors and switches and output devices attached here. So X0 is our start button, X5 is our stop button, Y0 is our inlet pipe of the liquid number 1, Y1 is our inlet pipe for the liquid number 2, Y2 is our outlet pipe which is attached at the right bottom side of the tank. So when the liquid gets mixed, so liquid need a part to exit from the tank. Here X2 is our sensor number 2, which is the middle sensor. X3 is our sensor number 1, which is on the top sensor. And X4 is our sensor number 3, which is attached in the bottom of the tank. So to test this, first of all we need to compile this program. To compile it, turn on the simulator mode and turn on online mode, click yes. And now run the program. Now initially the tank is empty, so first of all liquid number 1 starts to enter into the tank. To start or initiate the process, we need to press the X0 first. So I turn on the X0 and you can see that liquid number 1 starts entering into the tank through the inlet pipe number 1. As X0 is our push button, so X0 will turn off. And now you can see that liquid number 1 is now entering into the tank, and it will enter into the tank until our X2, which is our sensor number 2, is activated. It means liquid number 1 stops entering into the tank when it reaches the level of sensor number 2. So let's say that liquid number 1 reaches at the level of sensor 2. So sensor 2 will be activated, and you can see that our liquid number 1, which is denoted by Y0, is now stopped, and at the same time our Y1, which is our liquid number 2, starts entering into the tank. Now liquid number 1 was already present in the tank, and now liquid number 2 started to flow in the tank, and in this case our volume of the liquid will increase.
So in case of increasing the volume, our liquid level will raise. So liquid number 2 will continue to enter into the tank until our X3, which is our sensor number 1 attached on the top of the tank, gets activated. So let's say that our liquid number 2 reaches at the level of sensor X3, which is our sensor number 1. So when this activates, it means now liquids are mixed up. They are completely mixed into each other, and now when they are mixed, they are exiting from the tank through Y2. You can see that our Y0 and Y1, which are our liquid number 1 and 2, are now stopped, but our outlet pipe, which is attached at the right bottom side of the our tank, is now activated. So liquid is exiting from our tank. Now imagine a situation when when the level of the liquid start decreasing. So first of all, our sensor number 1 gets disengaged, which means level was at the top. Let's say here is our first sensor, here is our second sensor, which is sensor number 1, sensor number 2. The outlet pipe will active when this sensor gets activated. So when this sensor gets activated, our outlet pipe will get activated, and now liquid starting to decrease. So when decrease, the sensor number 1 gets disengaged. So here is our sensor number 1, which will gets into its original condition, and now liquid starts to drain, and liquids decreases its level more until it disengages our sensor number 2, which is X2. So this one also disengaged or turned off or turned into original condition, and now again the liquid is flowing out of the tank. The tank gets empty. So when the liquid hits at our last sensor, which is our sensor number 3, then our X4, which is our sensor number 3, gets activated, and it will stop the outlet pipe. I mean, it will stop the liquid from exiting through the tank. So if I turn on the X4 or activate the X4, then you can see our outlet pipe is stopped, which means no more liquid is going out of the tank. But instead, at the same time, our tank is now empty, and our liquid number 1 started to enter in the tank again, which means the process is now started again, which means our first batch is completed. Now for the second batch, again liquid number 1 enter, then liquid number 2 enter, they mixed up, and then they get out of the tank through the outlet pipe. So again, if we see the process, our X2 is activated, then our X3 is activated, but at the same time our X4 was turned off. So our outlet pipes is now gets activated, and now liquid starts to drain out. In that case, our sensor number 1 gets disengaged, our sensor number 2 gets disengaged, and then our X4 is activated. Liquid starts to enter into the tank, X4 will turn into its original condition, and thus this messy process continues till the end of the batch. So this was our example. So let's turn it off and turn off the offline mode, and then turn off the simulator. Close it.
So I hope that you get the idea of Latch. If you have any problem regarding today's discussed example, then please feel free to ask them in the comments below. In the next video, we will talk about LDP and LDF instructions. The link of today's discussed example are given in this description below. I hope that you liked today's video, so stay tuned till the next one. Bye bye.